Welcome to the Solution Nation podcast. My name is Sean Snowday, and I'm the president of Solution Nation. Solution Nation is dedicated to providing a platform for investors to learn about Israel's most dynamic public and private companies. We interview lead venture capitalists, Wall Street analysts, investment bankers, and managers of incubators and accelerators. Today's guest is Ravid Levy, and our topic is Israel's water industry. From desalination to water reuse, from smart metering to smart irrigation, from leak detection to new sources for powering water delivery, Israel is a world leader in water management. While many developed countries face water loss rates of 70%, Israel only loses about 5% of its water from source to tap. This podcast covers the gamut of Israel's water industry. Please remember that all content provided on the Solution Nation podcast and website is for educational purposes only. Nothing shall be construed as investment advice. Investment decisions shall not be made based on information, written, verbal, or otherwise, posted or spoken on Solution Nation. Conduct your own research or consult with your own investment advisors before making investment decisions. So here's my good friend, the host of the show, and the CEO of Solution Nation, David Wanatik.
Hello, everyone. Welcome to Solution Nation. My name is David Wanatik. I'm the CEO of Solution Nation. I'd like to welcome you to today's podcast. The focus of today's podcast is the Israeli water industry. Speaking on this subject, I'm very pleased to introduce Ravid Levy. Ravid Levy has some 20 years of experience in almost all facets of Israel's water industry. He is currently a senior director at WaterEdge.il, Israel's water innovation community. WaterEdge.il was founded in 2021 by Israel's Ministry of the Economy, Israel's Innovation Authority, its Water Authority, and the Kinneret Academic College. WaterEdge creates a network of professionals, entrepreneurs, researchers, and regulators to promote partnerships, problem-solving, technology development, and growth in the water industry. Ravid, thank you very much for joining us.
Thank you for inviting me, David. It's my pleasure.
Is there anything else you would like to say about your involvement with WaterEdge or any of the other consulting work or your past water experiences?
Just maybe a few words. So WaterEdge, as you said, very accurately, is a government initiative that aims to be a national water ecosystem coordinator, what we call community, but basically relating to the entire activities around water within the Israeli state and within the country as one ecosystem, including all levels, government, public, municipal, private, academic, NGOs, and other startups, of course. So all of them as one ecosystem that can work better together. And our task mainly is to cut some of the red tape, if you like, but mainly to connect and enhance communication between the different parts of the ecosystem in order to enhance innovative activity and adoption of innovation, both within the Israeli water sector, but also outside towards the global water sector. So we both work internally within all those bodies, but also represent the Israeli water industry and water activities towards the world, which is why I'm so happy to be hosted on this platform. Personally, I've been doing that. I've been doing water engineering and water innovation and water activity within Israeli technology companies that deal with water treatment, desalination, water reuse, industrial water treatment, and supply for a couple of years, actually decades. And so I'm very happy and privileged to bring this into this activity now to enhance the national water sector and activity.
Very good. Before we go into the Israeli water situation, I'd like to spend a few minutes talking about the global water scarcity problems, global insecurity caused by water shortages. Before you address this, let me just paraphrase a very nice quote from our President Kennedy. President Kennedy said, "Whoever solves the water problems will win 2 Nobel Prizes, one Nobel Prize for the science and one Nobel Prize for peace." So perhaps you can talk about some conflicts that arise in different parts of the world and where there's a lot of tension because of water scarcity.
Yeah, I would just like to add another quote from another great U.S. president. Way before that, said that when the well is dry, we know the worth of water. And I think that was Thomas Jefferson. But anyway, so and that refers to scarcity, and it means that when there's not enough of something, in our case water, then we start valuing that. But actually, lately, now with the climate change and the climate crisis, we also see that water is an issue not only when it's lacking, also when there's too much of it, like in flooding. And that goes both ways, or in rising sea level, or whatever. Actually, there's another famous saying or quote that says that if climate change is a shark, then water is its teeth. In other words, we feel the actual effect of everything climate through water, either from not enough of it, or from too much of it, or from the sea level, or from groundwater, or from lakes being changed and algae blooming in freshwater lakes, or whatever. So water is everywhere. Water is in the basis of all economical activity. Everything we buy, everything we eat, power we use, water is being used everywhere. So it's not just the water coming out of the tap and whatever we drink. People may think, all right, there's not enough water, let's go to the shop, buy a few more bottles. That's true if you have the resources. However, that water also comes from somewhere. And if you drive to the shop, you actually use water embedded in the fuel or in the car, and definitely with the food and the vegetables and fruits that we eat. So the challenge of dealing with water goes way beyond the net tap water that we feel and use every day. This is one. Secondly, we're privileged. Some of us are privileged to live in places where water is available. We open the tap, it flows out. And then we only feel the bite of the problem when there's suddenly a pollution event. Like now, there's something in Mississippi. There used to be something in, people heard about Flint, Michigan before. Once in a while, there's a crisis, and then, the modern society wakes up for not taking water for granted, but for the majority or much of humanity, water is not taken for granted. Water is not an available resource, definitely not safe or available running water. And that is also a global issue because as climate changes and more areas around the world suffer from drought or desertification, which is a permanent drought. Drought is actually not a very good term because it implies for something temporary. But if climate changes, then drought becomes, in some places, a permanent situation. And then more people will be stressed and more people will have an issue finding, their living and their resources, and that may lead to more migration, more unrest, political unrest in some places around the world, and we already see that. And I feel comfortable saying that because in a way this is what we experienced in Israel for decades. Since the inception of the country, we sit in a very arid area or semi-arid area. well, surrounded with some political or security issues with our neighbors, in some cases, actual war. And that reflects immediately on the availability of all resources, including water.
So just as far as flashpoints throughout the world, is water one of the points of tension between Pakistan and India? Or are there other cross-border tensions?
To some extent, not sure exactly that between Pakistan and India, because there are some other issues there. Actually, just now, Pakistan suffered some of the worst flooding in human history. It's a huge disaster over there. Hardly heard in some countries, like where we are. More people heard about the floods in Europe, Central Europe last year, which actually this year turns into one of the driest summers. So it's the same rivers that flooded Germany and parts of Belgium and Holland last year are now almost dry. So the extremes are everywhere. One of the biggest tensions at the moment around water is actually around the Nile River between Ethiopia and Egypt, because of a big dam that is being built in Ethiopia and will limit the river flows into Egypt. And that has a lot to do both with water availability, agriculture, but also power, because all those dams are hydropower dams. So it's a multifaceted situation. Actually, if you like, you can also refer to the water wars, which is obviously not a real war, but the tensions among U.S. states around the Colorado River, which is now practically not having enough water for everybody's needs, and there's an upstream versus downstream issues over there, and in other places around the world now, as I said before, we've been experiencing that around the Jordan River and the Sea of Galilee for decades. And so that's obviously a micro situation compared to those huge river basins, but can possibly be used as a reference for what can happen between countries or between states when there's not enough of the resource, and what can later, and we'll discuss later, what strategies can be made in order to overcome those challenges.
So focusing more on the Israel region, where does Israel's water come from? Does it come from the Kinneret that flows from Turkey or Lebanon or Syria?
Mm-hmm. So, well, naturally, Israel has three main water sources. One of them is the Jordan River basin, which includes the Kinneret or the Sea of Galilee, which some people, based on the Bible and some other images, may imagine that as a sea, but it's actually a pretty small lake compared to Great Lakes and other major lakes. So it's a pretty small lake, but it's the only freshwater lake, and it's fed mainly or almost exclusively by the upper Jordan River, which in turn is being fed by three sources. One of them comes from the Golan Heights, which used to be Syria before 67, and another one comes from Lebanon. And so there's a lot of and few other smaller streams that come from the different sides, including the Golan Heights. And so, and these are the only sources that feed that lake, which, as I said, is the only open surface water source in the country, or actually in the immediate region. So there's already some potential for tensions. Obviously, Lebanon and Israel are not the best friends, Syria and Israel as well. And so there's potential for conflicts over there, over that resource, which is limited by all parties involved. Now, the two other main natural water sources for Israel are two main aquifers. One along the coast, and the other one on the Judean mountains, where Jerusalem is, or the main mountain backbone in the center of the country. And so historically, the Israeli water supply since the inception of the country back in the 40s was based on these three sources. One of the earliest water planning and water strategies here was to dam the outlet from the Kinneret Lake. So in other words, to disconnect the Jordan River system from the Dead Sea, which used to be it's the lowest point on earth. And so that was the ultimate destination naturally of the Jordan River. But the outlet from the lake was dammed in order to keep the water within the lake. And then also we built back in the 50s the National Water Carrier, which pumps water from the Kinneret Lake, which is located at minus 200 meters below sea level. So there's a lot of energy involved in pumping water out of the lake and then channeling it all the way to the populated center of the country. So that was the main initial strategic project for Israel, to make sure that the water availability from the north becomes available for the population along the coast in the center, on top of drilling many wells out of those two aquifers. So up until the early 2000s, the late 90s, practically all water in the country was supplied from these sources.
Right? Okay. All right. So we have a good understanding now of why water management is important in Israel, because much of it comes from hostile countries. It flows through hostile countries. So maybe you can talk about the Israeli government's management of the water system.
Yes, so this is a very important point to stress, because it sometimes goes on a little bit under the radar when talking about technology and management and desalination and all that. But at the basis of the Israeli water strategy and the water policy lies a very, I think maybe a groundbreaking law, which was one of the first laws that were put by the Israeli parliament back in the 50s. And which is the water law. It's called the water law. The unique thing about this law is that it defines all water within Israel, either below or above ground, fresh or saline, dirty or clean, whatever type and whatever source, as public domain. There is practically no private water in Israel. All water resources, actually it was even expanded to include seawater at a certain point when desalination became an issue. So even seawater within the territorial area of the Mediterranean is regarded property of the public or the state. And that allowed few things, very important things. One is that there are no private water rights. There are only licenses that are given by the government. There's a central body, or the water authority, the National Water Authority, that was established in order to manage that resource for the entire population, for the country. And that allowed a very detailed and very strategic planning of how to maximize that resource and to optimize its use for the different applications. The other consequence of that is that every drop of water practically in Israel is being measured and being priced. There's a cost, different cost, but equal cost for different uses of different qualities and different quantities of water, either for domestic or for industrial or for agriculture or for yes, practically any other use. And there are very, very strict quotas of the different quantities and qualities. And that is updated annually according to the available resources. And so if there's a before, at least, where up until the 90s or the early 2000s, when natural water was the ultimate or the only source, every year, naturally, the rainfall changes and the level of the Kinneret Lake and also the aquifers changed. And the water authority sets annual quotas of different water and prices according to the demand and the supply. And that is a very, very basic element that allows planning and monitoring and allocating that resource, well, I wouldn't say maybe optimally, but as close as possible to that. And so it's impossible for anyone just to drill a well and start pumping water under their feet. They need the license and they pay back to the state for any quantity of water they are allowed to pump. So there's no free water around here.
Okay. So water going to the households in Israel, is it, you said there's different qualities of water. Is it specific enough to the household that you get the pure water going into the kitchen sink and, less pure water in the toilet or for gardening?
Not at the home level. The homes get just one type of drinking water, which is very high quality, by the way, also being managed quality-wise throughout the country by the Central Water Authority and by the National Water Company, which is the water producer and wholesaler. Mekorot, which is a pretty famous, the national water utility, was established also back then in order to manage practically and invest and put down the national water infrastructure. And then underneath that, or there are the municipal water utilities or authorities that are the retailers. They supply water to the homes and to the factories and to the actual users, and they measure and bill each one according to the use and to the quality and the type of water which is being given. At the home level, there's just one type. There are no dual or triple pipes. There's just one type. But agriculture, different irrigation water may be of different qualities and then can be priced differently, or water for the industry or other applications. So every user usually gets just one type of water according to their specifications or needs, but that type is being measured and being billed according to the centrally defined price list for different water.
So talking about government policy, it's my understanding that it's not easy to drill for new aquifers or even to put in pipes, water pipes under the ground. One has to get clearance from the Israel Antiquities Authority because Israel is a very historic biblical place, very sensitive about disturbing artifacts, and you need special permits for that. Is that right?
That's true, especially in some areas. Some are more historic or rich in antiquities than others. So that's another part of being able to do anything, actually any type of infrastructure, not only water. Specifically, the water infrastructure is governed and being licensed by the water authority. Depending on the situation, but it's not the important thing, which is very different from some countries, I think, including the U.S., is that the fact that you sit next to a river or on top of an aquifer does not give you any right in the water there. It still belongs to the public, and the public, through the government or the relevant authority, should allow you to use that at a certain quality and a certain quantity and times of the year sometimes. So if you're sitting next to the lake even, you're sometimes allowed to pump water and irrigate your, not garden, but probably if you're a farmer, your farm, but there will be a water meter there, and you will pay for that almost as if you were sitting anywhere else and irrigating your farm from the network. Because the fact that you're sitting on the coast of the lake does not give you any right in the water in the lake.
So when you say something to the effect that Israel controls every drop of water, is that is that hyper literal? So if it rains, does a farmer have a responsibility to collect the water from the rain? And
to a certain extent, there are also projects on rainwater or floodwater collection and dam. Also, they are usually this is done usually by the regional water utility or authority. There are several layers of that. In most cases, it's not done privately. And because also the investment in water infrastructure is the responsibility of those authorities, and that is being financed by the water bill, by charging for the water use for the different users. In fact, since the last decade or so, it's been decided that the Israeli water sector is a closed financial bucket, if you like, and so it must leave, or the resources are coming from the income which is done by selling or billing for the water, and also so all the national water infrastructure development and investment is being financed internally within the water sector by the charges to the different water users, and that also verifies that both prices and investment are in line with each other, and so it cannot be any major deficit, and every major excess, if there is any, will come back as investment in new infrastructure.
So two quick questions. How does the cost of water in Israel compare to other countries? And is there a movement for rationing water? So there was an article in the Wall Street Journal last week about in Europe, they're giving out timers, 6-minute timers for the showers. And in California, you have to ask for a glass of water at a restaurant. They can't just serve it to you.
So these are two different questions. The prices, as I said, are dynamic, and the answer is it depends. Household industrial water in Israel, I think I haven't done a survey, but I think they are on the higher range of prices compared to other, let's call it, developed countries. There are different countries around the world, and in some places water is actually almost free, either because there's a lot of it or because the population cannot just afford really paying much more. But compared to Europe and the US, I think it's more on the upper side. Irrigation water are usually less expensive, but also because there's, and we'll discuss it, that's an interesting point, which also concerns rationing or not. There's a big effort of supplying, let's call it marginal water, which is both, especially reused water or reused effluents and other non-drinking sources to agriculture, both in order to expand, to increase the availability of water and save on potable water to potable uses, but also in order to allow lower water costs for farmers that sometimes struggle to, or they're both sometimes major users of water. They need, of course, a lot of water to grow the crops, but also sometimes the ability to pay is lower, and so there are different water networks. Some of them are dedicated for supplying water to the agricultural sector in different qualities and different costs than to domestic or definitely to industrial users. Now, regarding rationing, so in a way we're ahead of the curve, if you like. So in the 90s, yes, there was strict rationing. There was a big campaign. As I said, up until the 90s, there was full or almost complete dependence on natural resources. So rainfall, basically. Now, rain down here happens something between 2 and 4 months a year only, which is the winter time. It's a very seasonal climate here in Israel. So we have 4 months of rain, which is collected, as I said, in one lake and few aquifers and several flood water or surface water reservoirs, and that's it. And if it's a good winter, as we call it, then reservoirs are full and everybody's happy. And if there are few years of dry winter or drought, then there's not enough. So back in the 90s, there was, then early 2000, there was a very serious drought or few years of below average rainfall. Population growth is pretty high in Israel. And so the combination led to severe shortage of water. And then there was a big campaign of water saving. There were a lot of, or there was a mandatory installation of dual flush toilets all around the country, and other water saving means for the homes, for showers and for taps. There were significant increase of water costs in order to enhance or to make people safe, right? And sometimes unfortunately, it's the best way of making people aware of a limited resource. So then it was going towards there, but then there was a strategic decision to change the water availability and to build another new water resource, which is desalination. And since then, Israel invested a lot of money, billions of dollars, in several major desalination plants. Actually, all of them, yes, today all of them were built in cooperation or combination with the private sector. So they are privately owned, yes.
Oh, yeah, maybe we can talk about desalination in just a minute. Let me just ask a preceding question. Are there any movements internationally to measure the amount of wasted water in various countries? And secondly, any efforts to measure the amount of power, amount of electricity it takes to deliver a liter of water? And how does Israel fare on those metrics?
So yes, you're right. There are two very important points. They say that every liter of water that is being wasted is the most expensive one, because you already supplied it, you already invested in that, and then it's been wasted. Now, people are aware more about the waste that they see. So an open tap or a leaking tap or something is high awareness, but unfortunately, a lot or the majority even of wasted water is done invisibly. It's done through the pipework, the pipelines that runs underground all around countries and cities, and the statistics are horrible actually in some cases. There are some cities that measure their the quantity of water which is being supplied compared to what's being billed to the public, for example, and they have something between 30 and 50% of water loss along the system. This means that for every a liter you take out of a lake or the aquifer, you treat it, you pump it, then only half of it goes out to the tap, and the rest just trickles and gets back to the ground, which is a shame, a huge way. Utilities call that non-revenue water. In other words, this is a huge financial loss as well, because that water cannot be sold or billed to anyone. It's just a cost that goes down the drain, literally. So there's lately there's a growing awareness of that around the world, especially, of course, in developed countries, but not only. And there's more and more efforts for one, measuring, because what you don't measure, you can never quantify, and you never know what's being lost. So measurement on both sides or all sides of the water network is crucial. There's more and more, speaking of measurements, there's more and more smart meters with remote sensing and the ability to read those things in real time remotely. They still, but there used to be people going around and reading the meters and logging that manually. This is gradually being phased out. Some Israeli companies are also leaders in those remote smart metering and transmission. In Israel, it's mandatory to switch all domestic water meters to smart, remotely transmitting meters by 2026, I believe. It's already about 50% through the process, and that increases dramatically the visibility of the system in real time. And the ability to measure and monitor the efficiency. And there are more and more technologies. Some of them are very smart. Some Israeli startups are specializing on sensing water losses and water leaks early on, and also repairing those leaks with minimal digging and excavation and all those works that are both expensive and bothering the public, especially within the cities. So there's a lot of efforts and a lot of technology that goes into the water networks in order to increase that efficiency and reduce the losses. So that's a major point.
Okay.
Yeah. Well, the other point was energy. Of course, that's a huge topic to discuss because it connects to almost everything. There's no modern water supply system without power and energy. And also there's a lot of energy going as well into the wastewater treatment afterwards. So power is a major cost and a major resource to the water industry. And yes, lately, both because of the energy crisis and other reasons and costs, but also because of the climate awareness and the emissions that are involved with producing power, there is more and more focus on energy efficiency everywhere around the water system: pumping, filtering, treatment, supply, wastewater reuse, wastewater treatment and reuse. Israel, because of desalination and because of the massive pumping from the Sea of Galilee, which is, as I said, below sea level, is of course using relatively more energy to supply water than in some other places where surface water is available and the desalination especially is still, although being improved significantly over the last couple of decades in terms of energy efficiency, is still relatively energy thirsty, and there's no other way to put that. And so it's important to use desalination only when crucial, when there's no other choice, I guess.
Okay. So overall, Israel is not doing so well in terms of energy needed to produce water because it's a lot of the water is found in very shallow places, and it takes energy to pump it upstream. And as far as wasted, maybe about average. Israel's doing maybe about average.
In fact, Israel also started very early on in measuring and minimizing leakages and wastage. In fact, the statistics now are around, well, definitely less than 10%, but some say less than 5% in the major cities of water losses, which is also ahead of the curve compared to other countries. Well, we should also probably say that the infrastructure in Israel, being a relatively young country, is also maybe a little bit less old than in some European cities and even US cities. But the performance and the adoption of technology for identifying and fixing and mitigating water leaks is already quite advanced, and the results are apparent. They are very good.
5 or 10% wastage is excellent. In some U.S. cities, it's 70%. Some of the infrastructure was built during the Civil War.
The target is zero, at least for Israeli utilities. So there's obviously the very final bit of saving is the most difficult and expensive to fix, but we keep improving, and the water authority keeps aiming higher and giving very ambitious targets for the utilities for keep reducing that, and that really enhances the adoption of advanced technologies, because now there are very interesting technologies involving satellite imaging or acoustic sensing and some ultrasound monitors that senses the leaks very early on, and also some interesting developments of like mini submarines that can go inside the water pipes and measure the potential for leakages, even or the thickness of the pipe itself to identify weaknesses and even fix the problems either when it's just starting to happen or even beforehand. So preventative maintenance is now becoming a very important buzzword within the water services industry, to identify the problems even before they're actually starting to leak water. Once you see the water coming out of the ground, it's probably, well, it's never too late, but you already lost a lot of it.
I definitely want to come back to this, these very interesting technologies in just a minute. Last question, sort of about government policy, is why is Israel's water management so much better than a place like California? Is it because Israel's centralized and California has many, many different agencies that may not coordinate so well?
It's very hard to compare specifically. They say that water is a global problem, but the solutions are always local. So every case is very different. But all I can say about Israel is, one, it's small. The small size of the country makes it much easier to manage water in a national way. So the entire country is actually being managed in one water network, and also wastewater network separately from that. And so yes, the government, the central planning and the ownership of the water by the public or by the state on behalf of the public allows planning of the resources very well, and the smaller size allows the execution of that planning to happen relatively or more efficiently. So if you take maybe California as an example, all I can say is that there are some things that maybe Israel, because of that, or thanks to those whatever we discussed so far, is maybe doing more efficiently. I must say that there are some other things that we should and we can and we do learn from places like California. If you take, for example, water reuse, Israel is very famous for being the number one in the world in water reuse. But that means that we reuse more of our wastewater than any other place around the world by far. So Israel reuses almost 90% of all the wastewater, the domestic wastewater being produced. All of that is being treated and reused back to agriculture, but only to agriculture at a quality which satisfies the agricultural needs and ability to pay. At the same time, in some places in California, and I don't know how many people in the US even are aware of that, but in Orange County and now in San Diego and soon in Los Angeles, there are major projects for treating and reusing domestic effluents all the way to a quality that allows what we call indirect potable reuse. So that wastewater will be or are already being treated to a very high quality, much better than what we do here for agriculture, and then being injected back in most cases to the aquifers in order to be cleaned even more and blend with natural water so it can be extracted back and be reused for any application, including domestic. We are here in Israel way ahead in how much or what is the percentage of wastewater that is being reused, but we still have a long way to go in terms of quality and technology that is being used in order to treat that water to higher quality. And so there are different aspects of being advanced in terms of water. There's always a way to go, and we're aiming further in all different aspects, including, for example, energy. As we said, we still have maybe too much energy is being used for the Israeli water sector. Of course, there are good reasons for that, like desalination, but there's still a way to go in order to minimize that and make that more efficient.
So with reuse, is the progress being made because Israeli companies are coming up with better filtration, or are they using more chemicals, better chemicals? And then secondly, as far as the energy that's needed to process water, is there some work going on as far as using the current of water itself to produce the electricity?
So for reuse, first of all, this is also part of the solutions for scarcity. So early on, it was obvious that if you just don't have enough natural resources, it's very wasteful to use the water only once. So if you can practically take much of that water and use it again, you will save a lot of fresh water for the same uses. And the decision in Israel, which is still valid, is that the destination for used water is agriculture. That's the strategy, which is both based on a decision, a health health authorities' decision that don't want to mix resources, but also it is possible because of the relatively short distances between the major cities that produce much of the wastewater and the agricultural areas. I remember when I lived in Australia that I was asking people there, why aren't you using wastewater for agriculture? And the answer was, just too far away. It will take so much energy and piping just to take the water to where the agriculture is that it doesn't make sense. So size does matter when it comes to water resources. And I guess the US situation is in a way similar, and which I guess is why some of California and possibly other cities in the US choose to take the reuse few steps further in order to allow reusing it within the cities rather than taking it to other places that are just too far away. And so it's both, it's a combination of policy and geography, I guess. Now about energy, So there are many ideas and ways to save and to optimize the energy use. Using the power of water itself is obviously a very interesting option, but you need elevation distances. And, we suffer from negative elevation distance. We need to pump water from under, or not under, but from below sea level of underground, therefore to invest power into that. So unfortunately, there are no hydropower or hardly any hydropower opportunities here in Israel. There are no major rivers or mountain lakes. However, technology sometimes comes to the assistance here, and there are several projects of what we call pumped storage, where artificially water is being pumped up when power is available or inexpensive, and then being used to produce back the power in other times. So in a way, it's like a hydraulic battery that preserves or stores excess energy and allows that to be available later. It's a very important tool when combined with renewable energy, especially solar power, which now gradually becomes a major power source in Israel. So the combination of solar power and the water sector, if you like, or the ability to use water as a means of storage, it might have some potential for increasing overall energy efficiency. And it's another aspect of what we call the water energy nexus. There are many interactions and many possibilities and opportunities with connecting water and power in different directions.
And what was that technology called again? Pump
storage.
Pump storage. Okay.
So in a way, you can imagine an elevated place like a mountain where you pump using power, of course, but you pump water upwards and store it up there, and then through another pipe and a turbine, you drop it down in other times to produce back the power. Now, of course, it uses overall some more power than it produces because of efficiencies, but it allows one of the challenges in power is how to store it. So batteries, for example, are a very inefficient way of storing power. Of course, it's available and a possible way of doing that. But on a large scale, this allows to use excess power when it's available, and in a way, converting it into water flow later on. So it's an artificial hydropower plant.
Okay.
And now Israel builds a few of those, and it's a pretty common practice in some places around the world to balance excess and insufficient power availability throughout the day or in different times of the year.
Okay, so we can talk about a couple more technology sectors, and if there's any companies, Israeli companies that you like in these sectors, you can mention their names. So you were talking about desalination, and I think you were saying it's still very expensive, still very energy demanding, demands a lot of electricity.
It's still energy demanding. It's not so expensive anymore. Depending on the energy cost, the cost of desalinated water dropped dramatically, and actually with quite a few engineering and technology innovations within the desalination industry and design. In fact, Israeli desalination plants keep setting world records in how low the cost of water is. They are all built, as I said, in some kind of a public-private corporation, or like build, own, and operate contracts by private companies, and they bid and compete for the lowest water price that is eventually being sold to to the water authority, to the national network. So Israel now has already five operating major desalination plants along the Mediterranean coast, and now in planning and on construction of one more and planning on two more that will be built within the next decade or so, which will be used in order to compensate for increased population and water use in general, and also to be some kind of an insurance policy against drought. Okay, so the cost of water out of those plants at the gate, at the valve at the end of the process, is now more or less around 50 cents per 1,000 liters per cubic meter, which is about half of what, or maybe even 1/3 of what it used to be maybe a couple of decades ago in all the desalination plants. So the overall cost is dropping, and one of the main reasons for that is higher energy efficiency. So there's a lot of technologies involved there for energy recovery and making everything a little bit more energy efficient every time. And now still possibly more expensive than just pumping water out of a lake. But when there's just not enough of that, it's now becoming a viable water source to compensate for that. As I said, it's not the cheapest, it's not the most energy efficient that you can find, but when the well's dry, you know the rest of the sentence.
So with building a desalination facility, do they have to be a certain distance from the coastline? Are they noisy? Do they cause pollution? Is there a limit how far from the shore the desalination plants? And also, can they be a target? Because they're probably not well protected. So,
that's an interesting point. You're right. I'll refer to that at the end. But first, the technical questions. It is more efficient to place it near the coast for two reasons. One, in order to shorten the lines of feed water from the sea, which actually is normally built long or further into the ocean in order to get more reliable but also cleaner seawater rather than close to the coast, and to minimize some environmental effects. Also, we need to remember, and that's about also pollution and environmental issues involved with desalination. There's the energy part of things, but also there's the brine. Brine is everything that is left behind when the fresh water is being extracted from the seawater. In principle, it's about half of the water that was taken out of the ocean with all the salts, or almost all the salts that were there to begin with. And that's 50% more or less, with twice the salinity, because of course all the salts are being concentrated in about half the water, is usually being sent back to sea, to the ocean. And there's a lot of efforts in order to minimize the environmental effect of that discharge. Usually it involves very long discharge lines into the ocean to allow better mixing and dilution. But we cannot ignore the fact that this is the downside or potentially a negative effect of desalination, and something that the desalination industry, if desalination is going global, and in some places it is, we must pay more attention, and there's a lot of the need for innovation and for research around extracting minerals, increasing the extraction of water out of that brine, and minimizing the environmental effect. So this is one side of things. So in most cases, desalination plants are along the coast. In places like Israel, where the coastline is a limited resource as well, we don't have so much. We're not California or Texas. We don't have so much such a long coastline. there's always a dilemma of where to locate those plants. They take quite a lot of area, and there's a big effort of locating them either within existing infrastructure, maybe next to power plants, or to places where the disturbance to the to virgin coastline will be minimal. Also, to upgrade and increase capacity of existing desalination plants rather than building more and more new ones. So that's another strategy to make it more compact and make more water out of less area, if you like. Now, the safety or the security side of things, obviously in Israel is a consideration. Today, I'm not sure I mentioned that, but today, desalination already supplies about half of the country's drinking water. I mean, if you take away or you disregard the reuse and some other resources of water, then it's about 50% of the drinking water, and it is expected to grow as more desalination plants will be built, because the other water resources are exhausted. We're practically already using all natural water resources, and every excess water that will come into the equation will practically come from desalination. And so those plants, now 5, in the future about probably 7, are definitely a strategic asset. And so there's also security and national strategy of how to defend and how to make sure that they are redundant. So if one becomes unavailable for any reason, then others can compensate for that. It's part of the national water strategy to defend those assets, not only to build and operate them.
So do people live at the desalination plants, or they'll go back and forth every day, or
no? Israel is very small, so they are located along the coast, also where most population live. It's not within populated areas. It's usually outside the big cities to prevent, both because they need quite a lot of area. It's like an industrial factory that is located along the coast, and there's a pretty small staff operates such a plant. It's mostly automated. Part of the technology involved is for automatic operation and optimization of all the production processes, throughout the day and throughout the year. There's a maintenance and operation team, and they come back and forth.
Okay. You want to talk a little bit about smart irrigation and metering and billing?
Yes, very important, because at the end, agriculture everywhere, and including in Israel, is still using more water than any other thing. I mean, most people don't realize that for every drop of water we use at home, someone else is using 2 or 3 drops for growing the food that we eat and everything, the clothes that we wear, and everything else that comes out of agriculture. So optimizing agricultural water use is crucial for general water saving and then water efficiency. This is again Israel. When the country was established, it was mostly agricultural, and agriculture was always a very important part of the Israeli economy and livelihood, as in every country. And so there was a very big focus on saving irrigation water and making agriculture smarter and more water efficient. This is probably why one of the most important and famous inventions coming out of Israel was the drip irrigation, invented back in the 60s by Netafim, which is a very famous irrigation company, but then been developed and commercialized by a few more Israeli companies, now practically working all around the world. And that was again, that's again a very interesting example of taking a need or a limited resource and thinking how can we grow more with less, if you like. And then on the back of that, there are many more innovations and many more technologies that come to support efficient irrigation and water use. And water use, I already mentioned reuse. So around reusing water, there's a lot of interesting challenges that needs technology, because reused water is obviously sometimes not as clean or has some specific characteristics, chemical or biological, that requires different means of irrigation and sensing. Now there's a lot of development of remote, but also real-time sensing of the water need of the plants and the soil, and adjusting irrigation to a specific plant and specific soil type. And all of that together translates to using less water to grow more food. And at the end, that frees more water for other things. And at the end, and overall, the national water availability is basically a zero-sum game. You know, you have a certain bucket of water, and that needs to be enough for everything, for everyone. And if someone uses too much, then someone else or something else will just not have enough.
Okay. Soil seems to be very variable. The soil 5 meters away can be very different than the soil you're touching. So anyway. Okay, so you mentioned, you kind of teased us. You mentioned some very cool technologies, satellite imaging, seismic or acoustic, and mini submarines, that kind of thing. Can you expand on that and maybe tell us some of the companies involved with those technologies?
Yeah, well, I prefer not to go into specific names, but the technologies are very interesting. Lately, so Israeli water industry and technology was there from the very beginning. There are quite a few very successful and globally known companies that do pipes and drip irrigation and valves and other things for many years, and they still do. But lately, actually, there is a trend which is very interesting, of what we call digital water, or the combination of the high-tech and software industry into the infrastructure in general and water infrastructure specifically. And these, in fact, combine two very important strengths of the Israeli economy and Israeli industry. One is, as I said, the experience and the many years that we have in managing and optimizing water resources. The other one is the high tech or the startup nation and the software and the data industry that flourishes in Israel, which is obviously well known as the startup nation, but it's now also a scale-up nation, because more and more companies on that sector is being based and growing out of Israel. And I think personally that combining the two may have huge potential. So there are more and more Israeli companies, like the technologies that we mentioned of remote sensing and leak detection and smart water monitoring, so both potable and other sorts of water real-time monitoring, that is growing and using big data and AI, and artificial intelligence software to manage the data that is embedded within the water networks. I mean, if you think about the water networks around the world, not only as something that transfers water as H2O, but it also includes huge amount of information about that water, its consumption, the energy that is needed to treat it and supply it. Everything we mentioned before can be optimized and can save a lot of water and energy and chemicals if you can measure, analyze, and process the data in real time. And using cloud computing, remote sensing, and generally digital technology is now becoming probably the most interesting part of the water business in general, beyond the water itself, the infrastructure, the hardware itself that will always be there. But making that a smart infrastructure is where the potential really is, because there's a huge amount of money, energy, carbon, whatever you want to measure, that is wasted just because we don't know what's happening underground and within our water all the time.
Is there anything specifically you want to say about the satellite imaging? How does that help with water management?
No, yeah, this is the technology that was developed by an Israeli company that takes specific satellite images and analyzes that to identify water leaks underground at a certain wavelength, very early on. So apparently, using a certain imaging technology from space can, if you like, penetrate to some depth underground and identify the fingerprint of water leaks. And that can assist covering large areas within cities or everywhere, and directing the teams where to dig and where to find those leaks before it becomes a major issue. Similar technologies are being deployed through a drone these days. So that's another way of covering a large areas using imaging technologies in order to, again, you can think about X-ray as a means to penetrate something from the outside without digging in or cutting in. So it's like making some kind of X-ray imaging, or it's not using X-ray, but a different technology, but to look underground without digging or to minimize the excavation. So that's a good example. As I said before, the other strategy is not to look from the outside, but actually look from within the pipe to send mini submarines or just sensors that can go within the pipes and identify those weaknesses or leaks from within and locate them, and then mark the location specifically for, at the end, we probably will have to dig in and fix the leak. But if you can save on unnecessary digging and excavation, but more importantly, to do that when it's still small, or even better, just before it really starts leaking, by identifying those potential weaknesses in the pipes and joints and other parts of the network. So
okay, great. The last question: where does Israel see more delegations coming from? Delegations of people from countries that have serious water problems?
Actually, in the last year or so, since I've been managing the WaterEdge.il, I've met many people from many countries. It obviously started or gradually picking up after COVID, but both. We have delegations coming from the US. We now are just before or organizing a very important delegation from the US, from utilities and government agencies focused on reuse, coming over here, and we will show them around mainly the reuse infrastructure and strategy that we just discussed. This is from, for example, from the US, but there are many delegations coming from countries like India, from African nations that are interested in different aspects of supplying water to the public and using that also for agriculture. There's a very big emphasis on agriculture infrastructure and irrigation efficiency. And so in a way, I think Israel can be seen as almost like a lab for water technology and management because one, it's small. So it's easy to just see almost everything that happens here, maybe within a week of a visit or something like that. But also because it has in a very small area, possibly all the different challenges. We have a relatively the north with the lake and the streams has some challenges and opportunities. The south is a complete desert, and then there's the coast, and all of that is a couple of hours drive from each other. And so there are so many opportunities to test and qualify technologies very efficiently before it goes global. And so that's why we really try to make the most out of these opportunities, plus know-how, the digital connections within the Israeli economy, and really want to highlight the potential here also for global players and international companies to come over here and develop and qualify and test the newest and the best technologies, and then take it to the world.
Okay, Ravid, thank you very much for a very informative podcast. We covered a lot. We covered really the whole gamut. So you were very kind and spent a lot of time with us and really educated us. So we really appreciate that. Thank you.
Thank you so much for hosting me, and I hope it was interesting. And I'm here to communicate with everyone who's interested in the Israeli water ecosystem.
Great. What's the best way for people to get in touch with you?
Via email or LinkedIn. I'm on LinkedIn, so you're welcome to connect over there, and we can take it offline from there. It's probably just search for Ravid Levy on LinkedIn, and we'll connect over there.
Thank you very much, Ravid.